What's up, guys? In this video we're going to be taking a look at fractional exponents, and this segment will be split into two parts. So in this video we'll look at unit fractions, and then in the next video we'll look at different types of fractions, like more complicated ones, like not unit fractions but like 2/3, 3/5. What would we do in those kinds of cases? How would we tackle them? Because it would be different from what I'm going to show you in this video, so I thought of doing it in two different videos. So without further ado, let's get to the video. So as you've already noticed, I've wrote some stuff on the board. So fractional exponents, if the exponent is a unit fraction. So just to make things clear, let A represent any real number, so any number, and then let n represent any positive or negative integer. Because in fractions, since we have a 1 over n here, if n were to be a fraction, then we would have 1 over half, and then we would get a whole number. And when we get a whole number, because 1 over half is 2, for example, if n was a fraction, we would get a whole number. A to the power of a whole number this rule wouldn't apply. So in this situation, in this scenario, let n represent any positive or negative integer. Okay, I'll show you how we handle negatives in the later on the video. So in that case, if the exponent is a unit fraction, now that I've defined the various variables for you, and if you don't know what a unit fraction is just when the numerator has a 1 in it. So for example, 1/3, 1/2, 1/6, 1/8, and anything that has even 1 over 20, that is a unit fraction. So in all these cases, the numerator is 1. So when the numerator has a 1 in it, that means it's a unit fraction. So just to make that clear. So let me erase this for you guys so you guys know. So in that case, we're introduced to a new concept now, which is the nth root of A. Okay, so now we're introduced to the concept of roots now. So I have written sort of my explanation to the root, so to the nth root of A, and I'll show you a couple of examples so you guys get the example. So the nth root of A is the result when we do this is a number or value that when taken to the power of n, so n corresponds to the n under the fraction, to the power of n, it will equal A. Okay, so basically the variables correspond with what's in here. So just I'll show you an example. So for example, A. Okay, so in an exponent problem, we would have a base. So base would be base, and then we would have an exponent, and then we would have a result on the other side. In a normal, so if it was like base squared, so base, for example, 4 squared equals 16. So 4 squared would be the base. 4 would be the base, 2 would be the exponent, and we would have to find the answer after. So we would have these two things, and then we would have to find the A value after. But when we're looking at the root, or when we're dealing with the fractional exponents like these ones, if the exponent is a unit fraction, you would have the A value. You would know your n value, so you would know how many times you would have to raise your base by, like how many times you would have to multiply your base by itself. You would know the power or the exponent, and the power or the exponent comes from the power, and the exponent comes from the n value from your unit fraction and the exponent. But your only missing value is your base. Your base, and that is basically the nth root. As I said, that the nth root of A is your base value. So you're trying to figure out that. That is basically what the root is. So now you're doing backwards. You have your A value, you know your n value, but now you have to figure out what your base is. So that is what we're trying to figure out in the concept of the root. So let me show you a couple of examples. 64 to the power of half. Okay, 64 to the power of half. Okay, so we have an A value. Okay, we have a unit fraction, it matches here, and then we have an n value of 2. So that equals the square root of 64. And since n is 2, we don't have to put a 2 here. If it was like, see how I put an n here? If it was like 3, 4, 5, we would have to put the 3, 4, 5 in here. But since this is a 2, we don't have to put anything here. It automatically, we assume that, or we know it's a square root. Oh, by the way, if n equals 2, it's a square root. N equals 2, the square root. N equals 3, it's a cube root. N equals 3, we're looking at the cube root. N equals 5, we're looking at the 5th root of 64. So that's how we would say it. So we're looking here at the square root of 64, okay? So the square root of 64, okay? So remember how I showed you in the other example, I showed you we had a base. Let's keep the base as, let the nth root, or the value, or the root of the square root of 64, the square root of a, which is 64, represent k, okay? I'm just going to assign a variable, okay? So k to the power of n equals 2, equals 64, okay? So and now we have our a value, we know how many times we have to multiply our k value by itself. So now we're going to square root it. So how would we solve it? Like how we do an equation. We put the square. When we put the square, the exponent and this will cancel out. Okay, so the square root cancels out our squared here, and what we do to the left side of the equation, the left side of the equal sign, we do to the right side of the equal sign. So k equals square root of 64, square root of 64, and you know that k equals 8. Okay, so if we plug it back, 8 squared equals 64. And if that is true, then your k value, it is true, so k value is 8. So you know that 64 to the power of half, or the square root of 64, is 8. So that is how you would solve it. So basically, see, I showed you how we get to this point. But like, this is a law of exponent, if you just want to know. So when we have a unit fraction, we take the nth root of your a value. So this is how we get here. I just wanted to show how we get from k squared, how we find the square root. So when we're looking at the root of, we're trying to find the base. We have a number, we know how many times we have to multiply our base by to get to that number, but we don't know the base. So in that case, we would use the square root, or square root, or the root. That is the concept of the root. And it won't always be perfect numbers like 8, 6, whole numbers. It might be decimal numbers too, but in those kind of situations, you'll get a calculator. So let me show you one more example. 125 to the power of 1/3. Okay, 125 to the power of 1/3. So based on our laws of exponents up here, we're looking at the third root. See how I put a 3 when we had a 3 in here? The third root of 125, or the cube root of 125. Okay, so when we're looking at the cube root of 125, we know our a value. We know our a value is 125. We're looking for our base. We'll use the same k variable. So let k, so the nth root of a is k value. K represent, and we know our n value, which is 3. 3 from here, comes from here. So we know that k to the power of 3, or k cubed, equals 125. So how would we isolate? We would have to isolate the k. So we would do the opposite operation. So we do cube root. So since we did cube root, the cube root and the cubed cancel out, or to the power of 3 cancel out. So k is by itself. What we do to one side, we do to the other side. So k, we know, equals 3 cube root of 125. So what is the cube root of 125? If you plug it into your calculator, you will know that it is 5. You will know that it is 5. So because 5 times 5, 25. 25 times 5 is 125. Just to show you guys how I got it. Because 5 squared is 25. 5 cubed, 25 times 5, 5. The 2 goes over here, 10, 125. So that's how you do, so that is how you tackle fractional exponents when you have a unit fraction. So we're going to look at the same example now. I said I'd show this to you in the beginning of the video. But what would we do if instead 125 to the power of negative 1/3? How would we tackle that? So this is a negative exponent. So we'd have to tackle negative exponents like how we did in the negative exponents video. So when we get that situation, it is, remember, 1 over, we bring the thing to the denominator, and we turn it into a positive exponent. Okay? 1 over 125 to the power 1/3. We already solved for 125 to 1/3. We know it's 1 over 5, or 1/5. So you can try plugging it into your calculator. You'll get maybe this in as a fraction form, and you'll get this in decimal form, which I believe is 0.2. 0.2, yes. So you would get 0.2 or 0.2, yeah. So that is how we look at fractional exponents if the exponent is a unit fraction. And this is how we do negative fractions, negative exponents, sorry. If the exponent is negative and it's a unit fraction like this, we would just calculate like how we would do for a normal negative exponents problem. So thank you once again for taking the time to watch the video. We'll meet again in the next one. Thank you.